Hello, fellow mathematicians. You are checking in with Miss Ledbetter, and we are ready to do some math. Today we are going to start a new unit. So in your interactive notebook, you need to create a new table of contents. This is starting Unit 2, which is our absolute value function. And this is the first concept or the first subject topic for Unit 2. So you need to continue in your interactive notebook. This is going to be recorded in your notes on page 7. And our topic for today is basically just going to be a review of linear equations and inequalities. So our goal is to find a value that will satisfy the equation or the inequality, or in other words, a value or a solution or a set of solutions that will make the equation or the inequality true. So resulting in a true statement is the goal. So we're going to start with just some examples focusing on the distributive property because that is a common place where students find errors. So if we begin, let's define our first function. Let's say that we have some equation where 4 times the quantity of m plus 12 equals a negative 36. And there's actually two different ways that we can simplify or solve this equation. The first method would be to simply do the distributive property where we would get 4m plus 48 equals our negative 36. And then simplifying from there to get the variable by itself, the goal is to isolate the variable, so using inverse operations. So I'm going to end up subtracting 48 on both sides of my equal sign. So 48 cancels out with when I subtract by a 48, leaving me with 4m is equal to now a negative 84. And then continue that to get the letter by itself. Then I'm going to divide both sides by 4. 4 divided by 4 is 1, so that results in m is equal to a negative 21. So that is the first method of how you can solve an equation with the distributive property. Or the second method, if we go back to our original equation, 4 times the quantity of m plus 12 equals a negative 36. Because all of the quantity m plus 12 is ultimately being multiplied by 4, I could simply first divide both sides by 4. And then 4 divided by 4 is going to cancel out, eliminating that 4 altogether. So then I just have m plus 12 left over equals now negative 36 divided by 4, which is a negative 9. Then continue, same process that we've done before, solving to get the letter by itself. So I'm going to subtract 12 on both sides. 12 minus 12 goes away. So now I have m equals negative 9 minus 12 is a negative 21. So in either method, you actually end up resulting in the same answer. So it just depends on how your brain works, or whichever method applies for you, whichever one makes sense. So let's look at some other types of equations. 16 minus 3 times the quantity of w plus 7 equals 19. A common mistake made by several students is to first look at this, if you read from the left to the right, first thing says to do 16 minus 3, which I know is 13, and then take the 13 to do the distributive property. However, if you keep in mind our order of operations, which says that we need to do parentheses first, which I cannot simplify the w plus 7, but there is a number sitting directly in front of the parentheses, which then therefore tells me to distribute or multiply. And again, I'm always going to multiply before I add or subtract. So a common misconception would be to just simply take 16 minus 3 and then continue moving forward in the equation. However, that would not be proper according to our order of operations. We actually are going to end up taking the negative 3 and performing the distributive property, or multiplying that quantity w plus 7. And I say negative 3 because the minus is actually acting as a negative for the 3 value. Remember that, keep in mind, every negative or every subtraction means adding with a negative number. So change any subtract to add with the opposite, adding a negative, makes that a -3. So then I would end up distributing that -3 first, which would give me 16 minus 3w minus 21 is now equal to the original 19. And then simplifying that, now that I have done the distributive property, I now have like terms. So if I have 16 and I take away 21, is going to leave me with now a -5. So now I have a -3w minus 5 equals 19. And just continue simplifying, add 5 on both sides. So the 5's go away. So now I have a -3w is equal to now 24. And again, divide both sides by 3, or -3. So then resulting in w equals a -8. So if I take the value of -8 and put it back into the original equation, then when I simplify all of that on the left side of the equation, it will simplify to equal 19, so therefore creating a true statement, 19 equals 19, satisfying the equation. Let's look at one more. Common misconception, a common mistake that several students make is something like this, where you actually technically have two distributive properties within the same problem. So most students would obviously see the first one and they would perform the distributive property as necessary. However, common mistake is just to simply subtract and forget about the second set of parentheses altogether. However, keep in mind, even though there's not a number there, there's an imaginary 1 sitting directly in front of the parentheses. So it's almost as if we are taking a -1 and distributing that -1 with the 7 as well as the minus p. So then when I do distribute the negative, I end up having a -7 plus a positive p equals 22. So now simplifying as we have before, now I have a positive 32 and I'm going to take 7 away from that, which is going to result in 25. And then if I have a -4p and I add another p, is going to leave me with a -3p equal to positive 22. Now I'm ready to start crossing the equal sign, ready to start solving. So now I would subtract 25 on both sides. So 25 minus 25 goes away. So I end up with a -3p is equal to now a -3. So then continue solving. Divide both sides by a -3. -3 divided by a -3 is going to be 1. So therefore final solution would be p equals a -1. And again, if I take the value of -1 and substitute that for every p on the left side of my equation, when I simplify all of that, should equal 22, ending up in a true statement, 22 equals 22. So now let's talk about the difference between solving an equation and solving an inequality. Equation implies that it is equal, they have the same value. An inequality, just in the name itself, is unequal, meaning we're not equal to each other. Therefore, applying the greater than or less than symbols, or less than or equal to, or greater than or equal to. So still, same concept, same rules still apply. We are still trying to find a solution or set of solutions now that will satisfy or make the inequality true to result in a true statement. However, there is one big concern, is that any time that you multiply or divide by a negative number when you are solving an inequality, you actually end up flipping or reversing that inequality symbol. So a less than would become greater than becomes less than, only if you have to multiply or divide by a negative number. And to simply prove that point, let's just take a simple fact that we know 6 is greater than or equal to 4. Yes, 6 is greater than the value of 4. So what if I decided that I wanted to multiply both sides of that inequality by 2? So if I take 6 times 2 would give me 12, and 4 times 2 would be 8. Well, 12 is still greater than the value of 8, so it is still a true statement to say that 12 is greater than or equal to 8. Nothing changed. However, what if I decided that I wanted to take both sides and multiply by a negative 2 in this case? So if I multiply 6 times negative 2 gives me a negative 12, 4 times negative 2 is a negative 8. So now it is no longer true if I say that negative 12 is greater than or equal to negative 8. Because of the negative values, it actually ends up reversing that inequality symbol. So negative 12 is now less than negative 8, and that was simply because I multiplied by a negative. So anytime you multiply or divide by a negative, just reverse the inequality symbol. So now let's look at an example inequality problem. So if I take 8a minus 2 is greater than or equal to 13a plus 8. So now, same rules still apply. I still want to solve the inequality the same as if I had solved an equation. So therefore, I am actually going to pretend that the inequality is actually an equal sign. I would treat it exactly the same way. So I still want to isolate the variable using inverse operations so that I can have the letter by itself. So first thing that I'm going to do is I notice that there are 2 variables. I have 1 letter on each side of my inequality, so therefore I want to eliminate one of them. It doesn't matter which one. I'm going to choose to eliminate the 8a just because I like to be a positive person and I like to keep everything positive. So therefore I'm going to eliminate the lesser value so that I can keep a positive value on my variable. So if I take 8a away on both sides of the inequality, then the 8a minus 8a will cancel. So now I have a negative 2, and pretending that's an equal sign, 13a minus 8a is now going to give me 5a plus 8. And then now solve exactly in the same way. So therefore I'm going to subtract 8 on both sides. So the 8 goes away, so now I am left with 5a is equal to a negative 2 minus 8 is now negative 10. And then to get the letter by itself completely, now I'm going to divide both sides by 5. 5 divided by 5 gives me 1, so therefore 1a, or just a, is equal to a negative 2. Now, the reason why I want to show my steps is that I can very simply go back and look, because this is an inequality, did I multiply or divide by a negative number? Well, I did end up dividing, but the value that I divided was a positive number. It doesn't matter that my result for my answer ended up as negative, but the value that I divided to get that is a positive. So therefore, I do not have to switch the inequality symbol. So therefore, I could still say that negative 2 is greater than or equal to a. However, if you are trying to graph this on the number line, if you wanted to reverse this so that you have the letter on the left-hand side, then you would say that a is less than or equal to a negative 2. Just to make sure that a is on the left-hand side so that you could graph that on the number line. So for your example, for you to practice, I want you to work this problem in your notes, and I will give you some time to work the problem so that I will give you the answer at the end of this video. But I just simply want you to analyze for yourself, to evaluate, solve this inequality. 2x is greater than 8x minus 24. And if you would like to pause the video to give yourself some time for you to be able to work this out, I will have the solution for you momentarily. Hopefully everyone has had a good day and you have enjoyed the lesson, the review for linear equations and linear inequalities. And we will continue working on these in class. So if you have any questions, concerns, or comments, feel free to contact me in any way. You can email me, talk to me in class. Just come find me and I will be willing to work with you. Hopefully you have had some time where you can work this inequality. If you want to pause the video to give yourself a little bit more time, be careful when you multiply or divide by a negative. It happens depending on how you solve this equation, this inequality. It's going to happen. So your final result for your practice problem should end up as x is less than 4. That should be the solution that you came up with. So therefore, any number that is greater than 4, not equal to 4, but any number greater than 4, when you take that result and plug it into the original function, will end up giving you a true statement. So that is all for today. Again, I hope you had a wonderful experience, and if you have any questions, just let me know. Have a great day. We'll see you next time.